Hello, everyone. We're going to give everybody just a minute or two to join. We still have a couple people who are coming into the webinar. So if you'll give us just a minute, we're going to get started. All right, let's get started. Ray, we have about 63 people on, so we're going to go ahead and get started.
All right.
Hello, and welcome to the Ohio Safety Process and Funding Course webinar series. This is part 2 of 4. My name is Paula Hyman, and I'm filling in for Victoria Beal from the Ohio LTAP Center. Before we begin, I want to cover a few housekeeping items. First, if you have questions throughout this presentation, I ask that you please type them into the questions box. Presenters will address your questions periodically throughout the presentation. So everyone, please locate the questions box or pod and type a little hello or a hi, just to make sure that you know where it's located and how it works. Lastly, today's presentation is available to download in the handout section. If for some reason you are unable to download the handouts, it was emailed prior to today's session. And if you did not get that email and you'd like to receive it if you're unable to download it, just in the questions box, send me your email address and I'll shoot it out to you. I want to thank you in advance for your participation. And with that, I'm going to pass things off to Raymond Brushart, our safety circuit writer. Ray?
Thank you, Paula.
You're welcome.
Good afternoon, everybody. I'm Ray Brushart with Ohio LTAP, and amongst other things, I'm a safety circuit rider. And so I'm all about safety. How's that? And so I'm teaming up today with Jeremy Thompson, who is a highway safety engineer in the Office of Program Management here at ODOT. His section is called the Highway Safety Program. He'll be joining me today as we talk about the Highway Safety Improvement Program, or the HSIP, as we'll be calling it. And as Paula said, this is a 4-part webinar, and we're on part 2. The first part, we went over the general stuff about ODOT's Highway Safety Improvement Program and the safety project process. And we talked about traditional spot projects and systemic improvements, or targeted and mixed projects. And so today we're going to simply focus on traditional safety projects. Those are the spot improvement projects and the application process that goes along with those projects. And we've got 2 Ohio specific examples of this type of spot safety improvement. So let's kick off by talking about the Highway Safety Improvement Program requirements. These are a brief rerun of a few slides from part 1, just to make sure we're all still on the same page about the HSIP. So I'm going to let Jeremy take over here on this one.
All right. Thanks, Ray. Again, I'm Jeremy Thompson with the Highway Safety Program here at ODOT. And I joined the program a few months ago from our traffic operations group, and I manage our local safety assistance program, as well as a few of our active transportation initiatives. You can go to the next slide, Ray. The purpose of the Highway Safety Improvement Program, it's a federally required program. We have to update it in order to get funding. And its goal is to reduce traffic deaths and serious injuries on all public roads. As of this past year, we are given $158 million annually to just allocate across the state for safety projects, safety studies, feasibility studies, signal timing studies, various things. And typically when we partner with a local agency, we require a 10% match to our funds. For eligibility, any public road with a minimum of 10 crashes over a 3-year period is eligible for one of these spot projects. That's just kind of the minimum criteria. But since we are a program whose goal is to drive down fatal and serious injury crashes, having a high representation of those can waive that minimum requirement. Any activity consistent with our strategic highway safety plan, also referred to as the SHSP, and corrects or improves a highway safety problem is also eligible. The SHSP has a bunch of different categories, from anything from intersection to pedestrian bicycle safety to work zone safety to run off the road crashes, that kind of stuff. And ineligible activities for this type of funding includes education and enforcement, although oftentimes education will be bundled along with a project so we can create resources to distribute statewide for educational purposes. Next slide. When we review projects, there's a multidisciplinary review committee that we use. It's usually anywhere from 15 to 20 people. It's our highway safety program staff. There's 6 of us. Our Office of Roadway Engineering, Traffic Operations, and local programs will sit on the committee. And then we'll have at least 2, usually a few more than that, district safety review team representatives from districts that aren't involved in that specific project to come in and review. I'll pass it back to Ray for this first polling question.
Now, if you are going to vote, please take yourself out of full screen. That way you'll have the ability to make the selection on your screen if anybody's having trouble doing the polling. Ray, go ahead.
Okay, well, I think, was I muted that whole time? So, yeah, it's a true or false question. If a location does not meet the requirement of having 10 crashes within a 3-year period, it is officially denied to receive any HSIP funding. So you guys select true or false. Are the answers rolling in, Paula?
They are.
Okay.
We have about 85% who voted. And just remember, we changed the question. To receive HSIP funding, a location must have had 10 crashes within a 3-year period. True or false?
Okay, well, that's enough. So the answer is false, because even the baseline requirement is 10 crashes within a 3-year period. However, if they are short of that number, but they have several severe crashes, like fatal crashes or serious injury crashes, then we'll waive that requirement. And one of the projects that we're going to talk about today is a good example of that. You'll find out. So today's learning objectives are that after today's session, you'll be able to understand the HSIP application process, and you'll be able to discuss what the review committee looks for as they decide which projects get funded. And you'll be able to appreciate the differences between rural and urban spot improvement projects. And you'll be able to realize that a wide range of projects can get funded. So we've got 2 very different projects to discuss with you today. So again, a spot safety project is for one location, either an intersection or a section, and they're able to apply for up to $10 million for each project. And so the first project that we want to talk to you about today is from the city of Newark. It's an intersection safety improvement project in the downtown of Newark. It's at the intersection of 4th Street, which is also State Route 13, and West Main Street. So a little background about this project. How did this project begin? Well, it was locally known as a crash hotspot. In fact, the city of Newark was able to work with LCATs. And Jeremy, what's LCAT stand for? Licking County what? Maybe you're muted.
Oh,
Licking County.
Licking County Area Transportation Study.
All right, so that's what LCAT stands for. So Newark is the county seat of Licking County. So they worked together. They knew about this intersection was a hot spot, and they were able to review the crash history, and it met the crash history requirements of 10 or more crashes in a 3-year period. It definitely met that. And so these types of projects, they don't necessarily need to be on any priority ranking list. They just knew that it was a locally known crash hotspot, and so they worked together. And then they contacted the ODOT District 5 office, and then discussed it further with them. And then they eventually they got in contact with Jeremy's office and made an application for the HSIP funding. And right now the funding has been allocated for this project, but the project, it's still fresh. It's not built yet. So this is hot off the presses. So here's a picture of the intersection, aerial photo of where the spot safety improvement will take place. As you can see, it's just a regular signalized intersection in downtown Newark. A little background on what the safety study entails. If you take a look at the safety study, it'll have these different chapters, so to speak. It'll walk you through the existing conditions, and then it'll proceed to crash data and analysis. And there'll be some discussion on the probable causes, and also what are the potential countermeasures based upon the types of crashes that are happening. And then they will take a look at will they propose a signalized intersection improvement, or will they recommend a roundabout construction in this location, because apparently there's other roundabouts in downtown Newark. So then they'll evaluate the both of those countermeasures, signalized versus roundabout, and then they'll have a conclusion about which one they will recommend. So the existing conditions in downtown Newark at this intersection is it's located in the downtown commercial zoning district. 4th Street is classified as an urban principal arterial, and West Main Street is an urban minor arterial. Both streets, since they're in the downtown area, have posted speed limits of 25 miles per hour. And so if we look at different legs of the intersection, you'll see that in the northbound and southbound directions, 4th Street has a left turn lane and a shared through right turn lane and one receiving lane. And the westbound Main Street has a left turn lane, a shared through right turn lane, and 2 westbound receiving lanes. Eastbound has a right turn lane, a through lane, and a left turn lane, and 1 eastbound receiving lane. And there's angled parking on the curbs and in the median on West Main Street, and parallel parking on 4th Street. There's also bike lanes on 4th Street that run from West Church Street to West Canal Street. And of course, sidewalks are present on both sides of the street in all approaches to the intersection. So as part of the first part of the study, first thing they do is they go out and do a bunch of turning movement counts to get a good grip on the traffic volumes, both for vehicular and pedestrian. And then they proceeded to do some crash data and analysis. So the crashes from the years 2013 through 2017 were studied. They had a total of 53 crashes occurred there. And in 2013, there was 15 crashes. In 2014, 11 crashes. 2015, there was 9. And in 2016, there was 10. In 2017, there was 8. And then of these crashes, 16 crashes, or 30% of them, resulted in injury crashes. So, and then 37 or 70% resulted in property damage only. The most predominant crash type on the corridor was rear-end crashes, which accounted for 30% of the total number of crashes. And then this crash type was followed by angle crashes. That's the most serious crash at an intersection where it's like someone blows a red light or something and someone runs right into the side of them. Some people call it a T-bone crash. So it's a very dangerous crash. Then there's side swipe passing and also backing crashes. So those accounted for 17, 13, and 7% of the total, respectively. So based on the detailed crash report, 16 crashes or 30% of all crashes involved a driver in the process of parking or leaving a parking spot. 2 crashes involved pedestrians and 2 crashes involved bicyclists. 3 out of the 4 pedestrian and bicycle crashes resulted in injury. And this intersection was identified as the highest pedestrian crash location in Licking County. A little bit more data for you. The majority of crashes, 74%, occurred at an estimated speed of 25 miles per hour and under. Crashes occurred predominantly on Wednesdays, followed by Mondays and Fridays, accounting for 30, 23, and 21% of the total, respectively. 63% of the crashes occurred between 12 p.m. and 5 p.m. And the highest contributing factor to the crashes in the study area was following too closely and failure to have assured clear distance ahead. In 26% of crashes, followed by failure to yield in 21% of crashes. Also, 77% of cases, the second vehicle was traveling straight ahead or was slowing or stopped in traffic. So also as part of the study, they wanted to discuss some of the recent construction they had in downtown Newark and the effects it had on the crashes. So some of the traffic operations around the courthouse square in downtown Newark were recently converted from a one-way in a counterclockwise direction to two-way. And the previous square operated with 3 or 4 travel lanes and angled parking along the majority of the square. And the square, which surrounds the Licking County Courthouse, underwent construction between 2015 and 2018 and now operates as two-way with 1 lane in each direction and roundabouts at the 4 corners of the square. Before the project, the block of Main Street between the square and 4th Street had 2 lanes in each direction with angled parking on the edges of the road and in the median. And now after the project, there's going to be 1 lane in each direction. There is 1 lane in each direction after that downtown construction. So they then looked into probable causes of these crashes. And they noted that based on the existing conditions, investigation, and the crash analysis, specific safety concerns have been identified at the intersection of 4th Street and West Main, and these include items under the categories of traffic operations, geometric features, and parking. So if we look at the probable causes under traffic operations, they noted certain things happening out there. When they were studying it, they found out that drivers turning left were observed navigating the turns at relatively high speeds, often cutting the corner of the turn, creating a larger conflict zone through the crosswalk and encroaching on the opposing left turn lane. Also, drivers were observed accelerating during the yellow indication or running red lights to avoid stopping at the intersection. And then during the peak period, cues from the through traffic on eastbound and westbound West Main Street extend beyond the entrance to the left turn lanes. And cues from the left turning vehicles on West Main Street also extend beyond the length of the turn lanes, blocking the through lanes on West Main Street. And then they noted these geometric features and other discussion about the parking. It says the large intersection footprint makes navigating the intersection more difficult for pedestrians and drivers. The angle parking on West Main Street begins close to the intersection and is difficult to back out of due to the proximity to the intersection and limited visibility. And the crash reports detail 16 crashes, or 30% of crashes at the intersection related to the angle parking in the median and on the curb sides along West Main Street, particularly on this section between 4th and 5th Street. So I'm going to turn it over to Jeremy now, and he's going to discuss some of the computerized analysis using the CAM tool and some things that were discovered through that.
Awesome. Yeah, thanks, Ray. Paula, if I could just get the presenter. All right. So first off, just on the screen, this is kind of this is our transportation information management system. It's like GIS based, and you just see a bunch of information here. So right now, what I've pulled up is this intersection that I'm hovering over is the intersection that we've been talking about, and all of these little hexagons, squares are ped and bike crashes that we've seen over the last 3 years. And then over here, I have the ADT and vehicular crash layers turned on. So you can see that there's definitely a dense amount of crashes at this intersection for vehicles compared to the ones around it. And while there aren't any ped and bike crashes directly at this intersection, it is an intersection of two arterials, and arterials are the most highly represented facility type for pedestrian bicycle crashes. So one goal of the roundabout would be to reduce speeds of vehicles, prevent angle crashes, and a one-lane roundabout is typically very safe for pedestrians to cross. Getting into the CAM tool itself, this is what we use to kind of start off our crash analysis. If you've ever taken our GCAT training course, that's you pull GCAT into the CAM tool, and the CAM tool, so all of this data right here is from our GCAT, our GIS crash analysis tool. And it's crash reports and all this data pulled from crash reports, like locations, crash type, crash severity, and information about the units themselves involved in the crash. So once this data is pulled in, we can start running reports. And running a simple report of this data will pop up with all these tables. So a lot of the information that Ray summarized over the last few slides came directly from this CAM tool. So we can see there are 53 crashes total, and they ran it over a 5-year period. We had a 30% of those crashes were injury crashes, sorted out by days of the week, hours of the day, types of crash, roadway conditions, lighting conditions. So all the information that gets pulled into these safety studies, or at least the preliminary crash analysis, is directly from this CAM tool, and a lot can be said from that. We see a lot of angle crashes and rear end crashes that makes up almost half of the crashes, just those two types. So this more raw data I guess, is what was used to create that safety study and come up with the conclusions that Ray's been talking about. Anything you wanted to add, Ray?
I don't think so. So, yeah, every type of crash is represented somewhere on the GCAT tool. Even pedestrians and bicyclists had their own segment in there as well, right? So, do you want me to get back to the PowerPoint?
Yeah.
Okay. So, let me show my screen here. Okay. Okay, so they went through and analyzed all the crash data, and then they began a discussion of potential countermeasures. So a countermeasure would be a safety improvement that addresses the specific types of crashes so that we can lower those types of crashes. So one of the things that was important here for this project was that the city of Newark already had a major project that was about to begin, and that's the 4th Street Sewer Separation Project, which runs along 4th Street, which is expected to be completed sometime this year. So that provides an opportunity to implement significant changes at the intersection of 4th Street and West Main Street. So that opened up the discussion for something other than just your typical traffic signal upgrades and improvements. So now the countermeasures included 2 scenarios. One is a roundabout at 4th and West Main, and then the typical signalized intersection improvements. So what they discovered was, after they did the analysis, computer analysis, that they projected that a roundabout would operate at level of service A during both peak periods with queues of traffic under 90 feet for all approaches. So that in itself is a really big improvement for that intersection. And then if they decided to go with the conventional signalized intersection improvements, that would operate at a LOS or level of service C during both peaks, with the countermeasures below incorporated into the synchro traffic model. Synchro traffic is the name of the computerized program that analyzes what the level of service would be. So if they installed the roundabout, if they were going to go this route, they would convert the intersection of 4th Street and West Main to a single lane roundabout. And along with that, they would implement a road diet and install streetscaping to the block of West Main Street between 4th Street and 5th Street. And they would increase enforcement related to motorist yielding in marked crosswalks, combined with a public education campaign, so that the public would be more aware of things like how to deal with pedestrians, and pedestrians would learn about, maybe they need to be taught how to properly cross the street. They would also review the bicycle network, and that would entail removing bicycle lanes from 4th Street and create a bicycle route connection that uses lower volume streets that are not state routes. If they were going to go the route of upgrading the signal, then what they would do they would reinstall the traffic signal at the intersection, and then do some of the same things that would go along with the roundabout. They would still implement the road diet and install streetscaping to the block of West Main between 4th and 5th, and increase the enforcement related to motorist yielding and the public education campaign, and also review the bicycle network, removing bicycle lanes from 4th, and create a bike route connection using low volume streets that are not state routes. So they went, after some analysis, doing some benefit cost analysis and such. Both amazingly, both projects, the price tag for either one was almost the same. I believe the roundabout was just a little bit more, but what they've concluded was that, well, first of all, they wanted to note that the intersection of 4th and West Main was analyzed in the safety study. It was identified as the highest pedestrian crash location in Licking County, and based on a field visit on the corridor crash analysis and engineering evaluation, a combination of traffic operations, geometric factors, and parking configuration were determined to contribute to crashes on the corridor. And also in light of the fact that the 4th Street Sewer Separation Project provides an opportunity to implement more countermeasures than just a signal improvement. Then they went on to decide that the roundabout scenario is what they recommend at this intersection. And so, with this study, it was reviewed by the review committee, and Jeremy, you guys went along with this conclusion, right?
Yep, sure did.
Okay, so I wanted to know, there's a polling question, and I know there was a lot of words on those screen. I didn't really know how else to do it. I know that's kind of a rule. You shouldn't make your screen PowerPoint slide so wordy, but I want to make sure that since everyone was requesting a printout or handout, that you had all that information on there. But I want to know how everyone in the audience feels today about if you lived in Newark, would you prefer to have the roundabout, or would you have preferred the signalized intersection improvement? So how about Paula, why don't you run that out there as a polling question?
All right, Ray, it is open. I have about 70% voted right now. And so far, we have about 82% who vote for roundabout and 18% who vote for the signalized intersection improvements.
Oh, okay. Oh, it's a big majority. I'm kind of surprised. Sometimes it's maybe it's because there's already some other roundabouts in downtown Newark, but I think we get varying feedback all over the state for different locations, especially if it's something relatively new in the area. You'd be surprised. A lot of people are not in favor of roundabouts, but the thing is, historically, about after some public education and a few months of people going through the roundabout after it's built, they actually totally changed their mind and they really like the roundabouts. That's been our feedback thus far. So do we have any questions in particular about this Newark project from anybody? Or any other questions so far? I take that as no. So, well, let's go ahead and continue then. Our next project is much different from the Newark project. It is a rural area, and it's not just an intersection, it's a corridor. So it's the Tuscarawas County Road 82. Yes, it's a county road, not a state route. Hang on here, I see a chat thing here. So there was a question about right-of-way costs. Is that right, Paula? So Jeremy, did you have anything to say about right-of-way? Apparently the right-of-way cost must have been part of the, they're not going out and buying additional right-of-way, I don't think, right, Jeremy?
Right. In the end, and one of the very positive factors of this project was that they were able to do this in the current footprint, and we allocated $20,000 to potential right-of-way impacts, but as far as I know, there have not been any.
Okay.
Yeah.
All right, so as I was saying, this next project is in Tuscarawas County. It's very different. It's a very rural area, and it's a county road, and it's County Road 82, which is also called Dover-Zor Road. And it's a corridor that stretches from Schneider's Crossing Road northwest, which is also County Road 80, to Middle Run Road, Canal Road, which is County Road 81. So it goes from station 2.92 to 6.58. So it's almost 4 miles long for this corridor. So a little bit about the background on this project. The reason for this project is they wanted to mitigate some safety issues at the intersection of County Road 82 and Schneider's Crossing Froman Road, that intersection. And that intersection had 1 fatality and 4 injury crashes in the last 5 years. And note that I said 5 years, not a 3-year period. This intersection, it actually did not meet the requirement for the number of crashes in a 3-year period, but due to the severity of some of the crashes, they actually looked at 5 years of data, and they went with those numbers instead. Did I say that right, Jeremy?
Yeah, and having 5 years of crash data readily available also allows us to see if there is any weird spike in a single year period or something that would skew the data, where in a 3-year period it just doesn't have that coverage for us to see if there's a random spike like that.
Okay. And then if we take a look at the safety study, it had these different chapters. It had, besides the introduction, it has a chapter for existing conditions and looking at the crash analysis over those 5 years. It also ran a multi-way stop warrant analysis for the intersection of County Road 82 and Zor Road. And it recommended some short and medium term countermeasures. And in the appendices of the study contains the traffic data, different crash diagrams. This is interesting here, a curve study, and that's throughout the entire corridor. This section of County Road 82 has lots of curves, so they studied each one of those curves and making sure that they had all the necessary advanced warning signs and guidance throughout the curves from beginning to end, like chevrons or a large arrow. Then there was a safety data summary that had a lot of the information that Jeremy just went over, like from the CAM tool and things like that. It also included a conceptual traffic control plan and a sample construction plan set, because some of the countermeasures were like removing some dips and hills on the road. So it'd be like a profile change. So, and you'll see here, we got pictures that there are some sight distance issues because of some of the hills and the dips and curves in the road. Let's see here. So in the introduction, it tells us that the purpose of the study is to evaluate the existing safety performance and to identify potential countermeasures to reduce crashes on this County Road 82. And it's also called Dover-Zor Road. And so this road, this corridor is a top 5 ranked location from Omega, which stands for Ohio Mid-Eastern Governments Association. And so it's in the top 5 ranked high crash locations for 2018. And the safety priority ranking takes into consideration crash severity and frequency. The crash data showed that the percentage of fatal and injury crashes were equal to 4.8 and 42.9% respectively. If we compared that to all the other sections of road, the statewide average for these roads would be 0.3% for fatal and 23.5% for injury. So this was well above average in both of those categories. So there were 2 fatal crashes that occurred within the study area. One fatal crash was a fixed object crash that occurred 1,900 feet north of Black Snake Hill Road, which is Township Road 380. It involved a single vehicle that rolled over on the east side of the roadway at 4:15 a.m. on September 16th of 2017, which was a Saturday. The other fatal crash consisted of an angle crash. Again, that's the worst type of crash you can have at an intersection. Occurred at the Schneider's Crossing Road Northwest, County Road 80 and County Road 82 intersection. And in that crash, an eastbound vehicle ran the stop sign and struck a southbound vehicle on Doversor Road around 2 p.m. on December 27th of 2017, which was a Wednesday. So County Road 82 is classified as a rural major collector. It's a north-south county route that connects the city of Dover and the village of Zor. And the Zor Village Golf Course is located near the north end of the study area. The Tuscarawas County engineer maintains this roadway. It's a 2-lane rural road having a pavement width of 22 feet. And they measured the speed out there. The 85th percentile speed was 47.6 miles per hour, measured at a location north of the Schneider's Crossing Road intersection. So I got some pictures from the study. As you can see, it's kind of a typical county road in rural Ohio. You can see some curves here. And in the distance, you can see a car pulling out of an intersection. So there's a stop sign ahead at an intersection. The new stop ahead sign design there. Here's another picture showing the approach for eastbound Middle Run Road. You can see the intersection of County Road 82 ahead. And then here's an example of a sight distance issue. So here's a Schneider Road intersecting with County Road 82. So you can see as we look here to the left that there's a hump followed by a dip. And so we can't really tell if a car is coming or not. And if a car is coming, they're going to be approaching at high speed. You know, it's a 55-mile-per-hour roadway. So sight distance is very important. So here's our crash map from for this corridor. Every dot you see represents a crash. The colors are different types of crashes. So you can see the 2 red dots, one here and one there. Those are where the fatal crashes occurred. And yellow is an injury crash. So you see there's several injury crashes here. And so they went carefully through all the crash data and analyzed it. And the crash data was obtained from the ODOT TIMS database, which consisted of total 42 crashes. They reviewed each crash report, which is called the OH1 for each documented crash, and they reviewed it for accuracy and to locate crashes that were within the study limits. And there's a breakdown of the percentage of each type of crash. Fatal crashes, 4.8%, injury crashes, 42.9%, fixed object, 52.4%, and half of the crashes occurred at night. Let's see, do we have a question? Let's see, we'll get to that one later. So here's a chart of a frequency chart of crashes by year and severity. And you see the green over here, that's the fatal crash. So both fatal crashes occurred in 2017. And so there are several intersections and curves throughout the corridor, but some of the locations had 3 or more crashes at those locations, and those locations are listed here: Middle Run Northeast and Canal Road Northeast intersection, the curve at Station 240, and that is the location of one of the fatal crashes. The curves located between Station 213 and 221, the curves between Station 164 and 175, and of course, the main intersection of this corridor is County Road 80, and it's also called Township Road 378. That's where the other fatal crash occurred, and also the curve at Station 125. So all those have 3 or more crashes. So at that intersection, they wanted to study it to see if maybe it meets the warrants for a multi-way stop sign installation. And so they went through the entire process of a multi-way stop warrant analysis, and they followed the methods that are shown in the OMUTCD, the Ohio Manual of Uniform Traffic Control Devices. And if you for an intersection to be a 4-way stop, it has to meet at least 2 of these criteria. And one is the vehicular volume entering the intersection from the major street approaches. Total of both approaches averages at least 300 vehicles per hour for any 8 hours of an average day. And so they looked at the volumes there, and it said the existing volumes on the major street approaches of County Road 82 are equal to 134 vehicles in the PM peak hour and 79 vehicles in the AM peak hour. So even the volumes in the peak hours did not meet the 300 vehicles per hour. So that obviously did not meet that threshold. And then they reviewed it for the combined vehicular, pedestrian, and bicycle volume entering the intersection from the minor street approaches. Total of both approaches averages at least 200 units per hour for the same hours, with an average delay to minor street vehicular traffic of at least 30 seconds per vehicle during the highest hour. So they reviewed it from that perspective, and it still did not meet the criteria for that. And then they also looked at it from the aspect of 5 or more reported crashes in a 12-month period that are susceptible to correction by a multi-way stop installation, and they said that that was not applicable to this intersection. So then we got down to the computer analysis here with the CAM tool, and also reviewing the curve study data. So I was going to let Jeremy speak to this one.
Yeah, Paula, I'll share my screen again if that's okay. Similar to the Newark project, the safety study was performed with first analyzing this crash data within the CAM tool. Like Ray mentioned, there were 10 crashes in a 5-year period, which, as we discussed at the beginning of this, is not our standard minimum amount of crashes necessary to get a project funded with safety dollars. But because 40% of these 10 were injury crashes and we had the fatal crash, then we decided to field the application and take into account when it came time to present. Just some other highlights: the angle crashes at the intersections specifically, just that vertical curve and profile alignment should help fix. Some standard systemic treatments along the corridor, like like signage, which was mentioned, also are a great way to mitigate some of these serious crashes, just bring more visibility to the corridor. And yeah, just same thing with the other one. The CAM tool is great for a preliminary crash analysis, and like it is done as the first step in most of our safety studies, or all of our safety studies. But it can be taken as a measure outside of a safety study, just to get a general idea of crash trends or issues that may lie at a certain intersection or certain segments that may be within your local agency's maintenance authority. So that's all I had. If you want to go back to the PowerPoint, Ray.
All right. All right, thank you, Jeremy. So after reviewing all the crash data, they then went into trying to determine what sort of countermeasures they can install out here that will decrease the number of those specific types of crashes. And so the most expensive part of the project was doing some profile work at the intersection of County Road 82 and Schneider's Crossing. To improve sight distance and maybe some realignment to make them a better 90-degree angle intersection, and some shoulder widening. And so the shoulders on the road there were 1 to 2 feet, and now they're going to be 4 to 6 feet wide. And also, proper signage and striping and things like that. So here would be this is an example of what the proposed project would look like in the form of a construction plan. So you can see through the dashed lines here how far the project is going to widen out the intersection a little bit better, and make it as close to a 90-degree intersection as possible. And so we're looking northbound. So in these areas here is where let's see, these areas here is where we're the profile would be changed as well. So in that one picture where we had a sight distance issue, that will be gone. You'll be able to see the approaching traffic from a much further distance. So there was excavation for vertical alignment revisions, improvements to the ditches as well, all to improve sight distance, embankment for fill areas for vertical alignment revisions. And as far as traffic changes, there'll be new signs put in for better advance warning. Also, pavement markings will be reapplied for double yellow center line on all 4 approaches, and also some drainage work as well, drainage pipes and culverts and things like that, better ditches for better drainage. So all this adds up to a much safer intersection than the existing. And then as far as the rest of the corridor, there was a lot of curve studies, so there are going to be a lot of new signs for better advance warning for the signs, and then also advisory speed plaques attached to the warning signs so that people will know what speed to slow down to get through the curve safely. And then there'll be some of them will have large arrows, and a lot of them will have more chevrons as well. And the chevrons provide guidance from the beginning of curvature all the way through to the end of curvature where the road becomes straight again. So, and then also there's some resurfacing and also new pavement markings for edge lines and center lines as well. So it will be a much safer corridor with all these improvements. So, so that's all I have for that one. Is there any questions that we have for this particular? I think was there a question we didn't get to through for the first project? Let's see what that one was. It says for the Newark roundabout, does the ECAT or GCAT analyze pedestrian crashes? Wouldn't PED crossing signals be safer for PEDs versus a roundabout? Do you want to speak to that one, Jeremy?
Yeah, for sure. That's kind of where a balance of these recommendations comes into play. I guess in our opinion, and from what we've seen, a single lane roundabout in a slow speed, like center of an urban environment, is just as safe for pedestrians. When we get into multi-lane roundabouts or at higher speed corridors, certainly pet heads could definitely be safer. It's pretty context sensitive. But in this case, we felt, or the consultant that was performing the safety study felt that was the preferred countermeasure at this specific location because of the context. And then as a committee, we did agree with that.
And then I was looking at the drawings too. It looked like there was with the roundabout, you eliminate any left turn lanes, so that kind of produces a pedestrian refuge, kind of like halfway across the street, doesn't it? Maybe not with concrete, but at least with striping.
Yeah, oftentimes the splitter islands will act as a pseudo refuge island for pedestrians. So it's like a two-phase crossing. They're only crossing one lane at a time. They only have to cross one lane.
I think I can show that picture. So as I can everybody see my screen? What do you see, Jeremy, on the screen?
Yeah, the safety study.
Yeah, like so here's a picture. That's kind of like where it's superimposed. But back here would be like a pedestrian crossing. So one of the main important things is when a car is turning right. I don't know if can you see my hand on the screen, the mouse? If someone's turning right, you know, in a roundabout, you have to be looking towards your left. So you're really focused on making sure no one's coming from the left, and then you pull out. So you don't want the pedestrian crossing right here close to the roundabout. So on this design, the crossing is put back here. So then the driver can refocus from left to the right and straight ahead, and they'll see the pedestrian better. So that's the reason for the crossing being here versus where the old crossing was. How was that, Jeremy? Was that a good explanation?
Yeah, that was great.
Okay,
do we have any more questions, Paula? If not, I can share my screen again, and I'll go through some of the things that the committee saw and some of the, I guess, additional recommendations that came out of both of these projects. Because there were some comments that were more suggestive or just wanted these projects to alter slightly. So I can go through that.
There are no questions in the box at this time.
Awesome. Okay. So when we're first presented these projects, the page on the screen is kind of our first glance. We just asked them to do a one-pager of the big hitter items. So you'll see that overlay of the roundabout, like Ray was just presenting, their score. And if you remember from last Wednesday's webinar, we mentioned that a score of 45 to 50 is what we constitute as a good score. So granted, this score was lower, but there were some things that we could do and suggest to bump this up. So one thing was this benefit cost ratio was a 0.7. And one of the things that we have to do when we're funding these projects is justify the cost. And usually cost justification means bringing this up to at least a 1.0. So our response to this application was offering the city of Newark 70% of what they asked us for, because then that would bring our benefit cost to 1.0. And they accepted it. They were willing to front that extra 30%. So that put a score in this box. And just beyond score, they are working towards making this roundabout countermeasure a corridor-wide thing or a system-wide thing in their city. So currently, they have these 4 roundabouts just east of our project location, which is where this pin is. So they have these 4. And beyond that, outside of this project, this north intersection right here is another one that they are pursuing a roundabout out that they are expected to handle solely themselves. And the graphic for that is here. So this bottom one is the roundabout that we're helping fund through this application, and this top one is another roundabout that they plan to put in just north of there. Yeah, beyond that, up at the top right here, they kind of laid out the difference between the signal and the roundabout for this project. So we can see the estimated costs current day were just 62,000 difference, which is very unusual for a signal. I'm assuming a signal would have required definitely some extra utility work and maybe additional right away. I'm not sure. I don't recall that layout specifically, but estimated 20-year costs, the roundabout becomes cheaper because it's way easier to maintain a roundabout than have to maintain signal equipment for most agencies. And that's about all. See, we saw as a committee on the Newark one. I guess I'll highlight both of these projects. Their safety studies were funded through our local safety assistance program that I manage now. And these were 2 of the first studies that we did fund through this program. So and we have about an 87% success rate in studies resulting in projects thus far. We've done about 50 studies through the program now. And then for the Tuscarawas County Road 82 one-pager, similar thing. They didn't necessarily include their scoring on this page. The BC ratio again was smaller, but we saw that their match of funding, they were bringing forward us the $643,000 number to the table through county funds and CEAO funds. And so their safety request was actually less than half of the project, which was a big benefit to this project. And being in a more rural, low volume context, it sets another place that it's hard to get these high scores on. So the committee took that into account when reviewing this project. I just wanted to add that tidbit that these 2 projects were picked because they either hit those minimum thresholds, or we saw things in the project, saw benefits beyond what the score may have shown. So I thought these were very good to highlight for that. Anything to add, Ray?
Well, when you say beyond what the score shows, I think what you said the last week in the first part was sometimes that involves pedestrian improvements and bicycle improvements.
Hey guys, we have a question. Doug asks, do you recall the cost of the studies?
A typical study costs us 30-ish thousand. Let me take a look. So for the Tuscarawas County job, we put in 38,000 for the study. So that they notified us that we had already spent $38,000 working towards this project. I usually estimate in the $30,000 to $35,000 range. I think this one, because it was a longer corridor, expanded beyond the intersection, and not necessarily just a spot study, it was a little more expensive. But in Newark, we don't have that information right here. But I'm going to assume this one was probably in the $25,000 to $30,000 mark, since it was just an intersection.
And the cost of that study, it came out of your program, right, Jeremy, not the locals'
Right.
pocket.
Yep.
So that's pretty important, right, locals? So yeah, that's one of the reasons we're having this series, is to let locals know that they can have studies done and projects done where it might cost them $0, right, Jeremy, in some cases?
Right. Yeah. I know this, we mentioned it last week, but this year we have been offering 100% project funding through our application process. Of course, that's all, they're highly revenue driven through the new user tax, gas tax. So that program might either be put on hiatus or not go as long as we want to, but that 90-10 rule is always going to be there. So, and that 90-10 rule, we don't want to apply to this upfront study stuff. So those will still be 100% funded. In every project today, and that we'll talk to over the next two webinars, the studies were done through this program 100% this with the state's money.
That's great. And just to reiterate how these projects happened, it was, the Newark one happened because the city was talking to LCATs about this high crash location, and they went on to contact the ODOT District 5 office, and then they contacted your office, Jeremy, and then
Right.
the other project started out as the county engineer was talking to Omega, and then they went on to contact the ODOT District 11 office, and then they finally, and then they went on to contact central office to get this on the locations to review by the review committee. So is there anybody out there in today's audience that they're on the fence or about some project they have in their area that maybe they're
Ray, I
yeah.
have a question. Does the same committee review the abbreviated safety studies?
So the abbreviated studies are typically only reviewed by one or two people within the safety program. That's the threshold to get approved for an abbreviated application or an abbreviated project is way lower. So we don't normally send that to a full committee unless we see we want to flag it for traffic operations or roadway engineering if we should involve them.
All right, good answer. Good answer, Jeremy. How about anybody else from the audience? They got a location that they want to talk about, or want to talk about anything? We've got some time here. How about we fill the time in with something from the audience? You can raise your hand or type something in the chat box. Well, again, here I am at this my final slide here. I just wanted to say, why did we select these two projects for today's course? And one was just to show you how they're very different from each other. One was an urban intersection, and the other one was a rural corridor that also had some intersections. And one met the crash criteria straight up by 10 crashes in 3 years. The other didn't, but was allowed to be funded due to they took into consideration the crash severity, and they also looked at a 5-year span of data. So anyway, that's all I have for today. If there's, I was hoping that we'd have some more questions from the audience or get some discussion going.
Got
Is there
one that just
anything?
came in, Ray.
All right.
All right. For the Newark project, how were the parking conflicts considered for existing movements and roundabouts where vehicles are constantly moving with limited time to stop, exiting the roundabout to check for pedestrians and parking vehicles pulling in and backing out or stopped waiting for a spot? And I'll copy this to you all.
Yeah, right. So that's definitely something that was taken into consideration. And as far as I know, we did suggest that parking was pushed back away from the intersection more. And all of this would be determined during that early preliminary engineering and environmental clearance. One aspect of environmental clearance with a job like this would be to do a parking impact study, and that study should include the safety of those trying to pull in and out of their spots. So while it wasn't necessarily something that was decided when we approved this application, it was something that was to be studied further with the approved funding.
Well, plus there was parking in the median before. That's gone in the new project, right?
Right.
So that lessens the conflicts. I know another thing that we've talked about is back-end parking. Was that something considered, or is it still the head-end parking?
We will touch on that when we talk about the Coshocton systemic analysis. But
Okay.
yeah, I guess if an easy way to, if you're having parking safety issues with your parking in your city, and it is front pull-in angle parking, we know that keeps more parking spots than standard parallel parking. So a good way to make that safer is to change it to back-end angle parking, so you can keep the same amount of parking spots, but it is safer than front angle parking.
Looks like we have another question. What is the average daily traffic threshold for a 1-lane versus 2-lane roundabout? And when might one step up to a 2-lane roundabout? Just a ballpark number.
Yeah, I'm not a roadway engineer, but from what I've seen, usually I think it's the addition of the 2 crossing streets shouldn't be more than that 20 to 25,000 range. Under 20,000 would be a single lane, and over 25,000 would be a dual, and in the middle you'd have to do some further analysis, just as a high level starting point. Of course, the analysis should always be done.
Yeah, it probably has a lot to do with parking maneuvers and things like that.
I know I don't have too much experience with modeling roundabouts, but modeling signals, there's all these peripherals that you have to throw in there that it's not cookie cutter everywhere. So.
Okay, good question. And about the other one there, I thought that was the way you're moving parking further away from the intersection will eliminate some of those high crash. That's probably more of the high crash parking maneuvers were the ones that were closest to the intersection, probably. Okay, so do we have anybody else want to hit the raise their hand button or anything before we take off for the day? I know our part 3 will be on Wednesday, and Let me make sure I say the correct time this time. So looks like 10 o'clock. 10 a.m. Wednesday will be part 3, and in part 3 we'll be looking at systemic safety improvements. And then the next day on Thursday afternoon from 1 to 2:30, we will wrap things up with part 4, where we talk about some pedestrian safety improvement projects. So if that's all for today, I want to thank everybody for attending today, and look forward to talking to everybody on Wednesday morning. All right. So goodbye.